Let's talk about rules of exponents. The first rule is a to the power of 0 equals 1. I want to point out here that a is our base and 0 is our exponent. So here are some examples of this rule. 3 to the power of 0 equals 1. X to the power of 0 equals 1. X minus 5 to the power of 0 equals 1. The square root of s to the power of 0 equals 1. And 9 over x raised to the power of 0 equals 1. Our next rule is a to the power of 1 equals a. So in these examples, I have 3 to the power of 1 equals 3. X to the power of 1 gives us x. 3 minus x raised to the power of 1 gives us 3 minus x. The square root of t raised to the power of 1 gives us the square root of t. And 1 over x minus 5 raised to the power of 1 gives us 1 over x minus 5. The next rule I want to show you is when we have a raised to the power of negative 1, we get 1 over a. So in this example, I have 4 to the power of negative 1 equals 1 over 4. This next example is x raised to the power of negative 3. And we rewrite that as 1 over x cubed. This fourth rule is the opposite of this third rule. It says 1 over a to the negative 1 is equal to a to the power of 1, which gives us a. So in this example, I have 1 over 2 to the power of negative 3. We can rewrite that as 2 cubed, and 2 cubed is 8. This last example, I have 1 over w to the negative 5th power, and we just rewrite that as w to the 5th power. This next rule says a to the power of m times a to the power of n equals a to the power of m plus n. I'd like to point out that for this rule, we need to have bases that are the same. So in this example, I have 2 squared times 2 cubed equals 2 to the power of 2 plus 3. That gives us 2 to the power of 5, and 2 to the power of 5 equals 32. This next example, I have t to the power of 4 times t to the power of negative 5. That gives us t to the power of 4 plus negative 5. When we add 4 plus negative 5, we get t to the power of negative 1. And we don't want to leave negative exponents in our final answer, so we will rewrite this t to the negative 1 as 1 over t. The next rule I have for you is a to the power of n divided by a to the power of m is equal to a to the power of n minus m. Once again, for this rule, the bases have to be the same. So in this example, I have 2 cubed divided by 2 squared. That gives us 2 to the power of 3 minus 2. 3 minus 2 is 1, so that gives us 2 to the power of 1, and that equals 2. In this next example, I have x to the power of 4 divided by x to the power of 6. That gives us x to the power of 4 plus negative 6. When we add 4 and negative 6 together, we get x to the power of negative 2. We don't leave negative exponents in our final answer, So our final answer is 1 over x squared. The seventh rule is a times b raised to the power of n is equal to a to the power of n times b to the power of n. So here I have an example of 4x all raised to the power of 2. And you can just look at this example as a way of distributing the exponent to each value inside the parentheses. So we distribute 2 to the 4 and we distribute 2 to x. 4 squared is 16 and x squared is x squared. So our final answer is 16 times x squared. This example, I have 3 values all being raised to the power of 3. So once again, we can distribute this exponent to each one of our bases. So we have 2 cubed times s cubed times t cubed. And to simplify our answer, we know that 2 cubed equals 8. And then we have s cubed times t cubed. Now this rule says a divided by b, all raised to the power of n, gives us a to the power of n divided by b to the power of n. So in this example, we have x divided by 10, all raised to the power of 2. That gives us x squared divided by 10 squared, which equals x squared divided by 100. In this example, we have 3 times x divided by y, all raised to the power of 3. And we'll distribute this exponent to each one of our bases in our problem. So we rewrite this as 3 to the power of 3 times x to the power of 3 divided by y to the power of 3. 3 cubed is 27, and so we have 27 times x cubed divided by y cubed. This rule says a to the power of m all raised to the power of n equals a to the power of m times n. So in this example, we have 5 raised to the power of 2 all raised to the power of 2. And that gives us 5 raised to the power of 2 times 2. 2 times 2 is 4, and so we have 5 raised to the power of 4. And 5 raised to the power of 4 is 625. Here's another example. We have 2 to the power of 3 times a to the power of 2, all raised to the power of 2. And so when we distribute this exponent to each one of our bases, we get 2 raised to the power of 3 times 2 times a raised to the power of 2 times 2. 3 times 2 is 6, and so we have 2 to the power of 6. And 2 times 2 is 4, so we have a to the power of 4. Now 2 to the power of 6 is 64, and so our final answer in this example is 64 times a to the power of 4. So now let's look at a few examples where we are combining the rules of exponents. In this problem, we have 6 times x to the power of 7 times y to the power of 5, all divided by 3 times x to the power of negative 1. So 6 divided by 3 equals 2. We have this x to the power of negative 1, and we can bring that to the numerator, and so we have x to the power of 7 plus 1. And then we have y to the power of 5. And so this further simplifies to 2 times x to the power of 8 times y to the power of 5. Now in this example, we have 3 times x to the power of negative 3 times y to the power of negative 2, all raised to the power of negative 2. So first we'll distribute this exponent to each one of our elements inside the parentheses. So we have 3 raised to the power of negative 2. We have x raised to the power of negative 3 times negative 2 times y to the power of negative 2 times negative 2. Now since 3 is being raised to a negative exponent, we'll move that down to the denominator. Now negative 3 times negative 2 equals positive 6. So in the numerator we have x to the power of 6. And then for our base of y we have negative 2 times negative 2 equals positive 4. So y also remains in the numerator. So our final answer is x to the power of 6 times y to the power of 4 divided by 9, because 3 squared equals 9. Now in this example we have r raised to the power of 2 times s raised to the power of 3 times t raised to the power of 4 divided by r to the power of 2 times s to the power of 4 times t to the power of negative 4. And so r to the power of 2 divided by r to the power of 2 cancel out. And for s to the power of 3 divided by s to the power of 4, we can use our rule that says a to the power of n divided by a to the power of m equals a to the power of n minus m. And so we have s to the power of 3 minus 4. And for our t raised to the power of 4 divided by t raised to the power of negative 4, we can use the rule of 1 divided by a to the power of negative 1 is equal to a to the power of 1. And so for our t, we have t to the power of 4 plus 4. So 3 minus 4 is negative 1, and 4 plus 4 is 8. So we have s to the power of negative 1 times t to the power of 8. We want to remove any negative exponents from our final answer, and so we have t to the power of 8 divided by s.